Hello everyone, myself Dr. Anju Mishra. I am Associate Professor in the Department of Information Technology, Ajay Kumar Garg Engineering College, Ghaziabad. So today's topic is about data streams. A data stream is a continuous ordered sequence of items, and the ordering can be imposed in two ways. It could be implicit by using the entrance time. So entrance time is one of the aspect by which the stream could be ordered, or there could be an explicit timestamp that is going to be assigned to each of the items. So one of the aspect about stream data is that it is very difficult to control the order in which these data items are going to arrive to the system, and it is also very difficult to store the entire stream into some working storage to process it further. And this is because of the enormous volume that we have with our streams. And another aspect is that items are arriving at a very high rate. So it is also a challenging task to keep track of the items that are coming to the system with a very high speed. So data stream is a sequence of tuples. We can thought of it as a sequence of attribute or as a tuple, and each tuple is going to comprise of a set of attributes similar to a row in a database table. And as we can pose different kind of queries over the database to find out certain insights about that particular data, similar ways we also can store and pose queries to the data streams to find out different types of insights about the streams, and then we can use these for improving our business or for this day-to-day decision making. So data stream contains different sets of data that depend upon the type of data format that we have chosen to store that particular stream. Now, streaming is the process of transmitting a continuous flow of data which is fed into a stream processing software to derive valuable insights from it. And a data stream consists of a series of data elements which are ordered in time. That data represents an event or a change in the state that has been occurred with respect to a certain business. And for a business, it is very useful to know about and to analyze this change of data specifically in real time to get to get the true decision making. Some examples of data stream can be, for example, we can have sensor data. So data is being sensed by different types of physical sensors, and they are sending the data at a specific rate, and we need to analyze these data in real time to get the insights from that. So for example, this could be, for example, a weather application where we have put sensors at different geographic locations, and those sensors are sending us different types of parameters regarding the climate. So this could be temperature sensors, there could be humidity sensors, and they are sending those numerical values constantly to our system. Now the responsibility of the system is to analyze this particular data and to make insights about the future climate conditions and all. Another application could be the activity logs, from where the data is going to be generated as a stream, and these could be from different types of web browsers, and financial transaction logs. So data stream can be visualized as an endless sequence. This endless sequence is the most important property of the data stream, as endless means that we cannot predict when the stream data is going to end up. So it is important that we are not waiting for getting the complete data, rather we need to do the processing on the fly. Each item in the stream may carry following fields or the attributes. So every item or every data piece can have one timestamp attribute which helps to identify when an event has actually occurred. Or there could be subject ID field. So this is most of the time is encoded by some algorithm that is handling the stream data. And for example, there could be a scenario where there is a web session is going on between the server and the client, and the algorithm is assigning the subject ID based upon the data fetched from a certain cookie. Now, the data could be in two formats. Data could be a raw data. So raw data is the stream data that is just recorded or is being sent or produced from the producer, and there are no kind of pre-processing or some cleaning functions has been applied over this data. So we are getting the raw information, and now we need to analyze this. So this is one aspect. Another thing is that the processed data, so data could be processed, the stream data could be processed by some intermediate parties. This intermediate party would be an algorithm or a software that is cleaning and pre-processing the data before the data is going to be further analyzed. Now, when we talk about the characteristics of data streams, so there are multiple characteristics that we can find out. So first thing is that the large volume of these data streams, and this volume is kind of a never-ending process because the data is being sent continuously or recorded continuously and being sent to the processor, and this type of streaming is possibly infinite. So we are saying it infinite because we cannot predict the end of this stream. And the next important aspect is the time sensitivity. So time sensitivity is again important in case of data streams, because we are not interested in analyzing the older or the historical data here. Most of the time the application demands the current data or the most recent data to be analyzed in real time, and they are making their decisions based upon that analysis. Another characteristics is continuously changing and requires a fast real-time response. So this is one important attribute of the stream data, that we need to generate the real-time responses. These responses could be in the form of the analytics that we have done over the stream data. And random access is expensive with a single scan algorithm. Next characteristics is the data stream is a volatile and unrepeatable stream of data. So unrepeatable means because data is being sent with a very high rate, so it may be not easy for us to repeat the certain data again and again. Rather, there could be systems those are storing that stream into some archival store, so we can refer to the older data whenever we want, but again that is going to be expensive. Stores only the summary of the data seen so far, so we are only interested in storing the data that we have already seen. And maximum stream data are at a pretty low level or multidimensional in nature, so we need multi-level and multidimensional algorithms and softwares or treatment that needs to be applied over this kind of data. Now, when we talk about the types of data streams, the data streams can be majorly categorized into two categories. One is called as the bounded streams and the unbounded streams. So a bounded stream is the stream which has a definite start and an end point. So it is a kind of stream where we can mark the beginning and the ending. So for example, if this is the stream data, this is the starting point and this is the ending points. So if I'm only considering data from this point to this point, then in that case it becomes a bounded stream. And if my stream is bounded, then of course I can store all of the data into the memory, and then I can analyze the whole data and I can make more insightful decisions or analysis over this data. Now, operations, for example, sorting and summarization can be performed more easily over a bounded stream, and the processing of bounded stream is referred to as generally as a batch processing. When we talk about the unbounded streams, the unbounded stream is not going to have specific endpoints. So for example, we are having certain initial markers from where the data is starting to be recorded, but the endpoint is unknown to us. So we need to analyze this kind of data on the go. And since the stream is a never-ending process. We need to continuously process the stream, and we need to generate new information whenever new data is going to be added to the stream. Now, the data is processed based on the event time, and the model of processing, unbounded stream, is generally referred to as the stream processing paradigm. Now, when we talk about the streams, there could be certain sources that are generating the streams, and there could be different types of sources that we can have. So, for example, this slide presents some of those data stream sources that are generating data continuously. So, for example, we can have data stream from credit card purchases. There could be telecommunications. So, we can have data from phone calls from the caller to the dialed parties. Then we have data by clients which are accessing some website, and there could be sensor networks, IP network data, earth climate related data that we are getting with the help of different types of sensors. Then there could be e-commerce sites data. So we are having purchase data of different customers. Stock exchange is another application from where, or another source from where we are going to have huge amount of data. And social media, as we all know, is one of the major producers of the data at a very high speed. So, for example, if we want to do the real-time sentiment analysis of the users that have joined the social media, for them we need to analyze the data. Now, when we talk about the major sources, so most of the time we are having sensor data. So, for example, in navigation system, this data is going to be used. And for example, if the problem is that we need to measure the temperature of the ocean, and we are analyzing this kind of temperature drips and temperature rises. If, for example, we are talking about the ocean surface is not steady. So maybe for temperature, we are going to have certain number of readings per day that have been taken up by the sensors. But for example, if I need to find out the surface or the rise and the downfall of the surface of the ocean, that is a ever changing process. So for that, if if we are getting the data, that will be a continuously changing data, and that will generate huge amount of data, maybe more than certain terabytes that we are having per day or on per day basis. And we need to think about how we are going to process this kind of data in real time, so that we can generate specific insights about the ocean surface and its activities. The next important source for stream is the image data. So image data can be can be through the surveillance cameras, or it can be from the satellites. So satellites, those are sending the pictures of the earth from different angles. Okay, it can generate a lot of image data that needs to be analyzed, and based upon that, different types of decision making is being done by the scientist. The third important source of the streams data is the internet and web traffic. So for example, if there is a node in the center of the internet that receives streams of IP packets from many inputs and forwards them to the desired output nodes, that again becomes a lot of data. For example, Google receives 100 millions of search queries per day. So millions of users are using Google service to find out different types of answer to their queries, and this becomes in total a lot of data to be handled per day. Similar ways, Yahoo accepts billions of clicks per day on its various sites. Many interesting things we can learn from these streams. So for example, if there is an increase in queries, like for example, fever and shivering, so people are searching for this type of query more at a specific interval of time, then we need to find out that whether there is a spread of some viral disease in that particular location or that area or not. And for example, a sudden increase in the click rate for a link could indicate that, you know, there could be some important news which is being floated. So many clicks are, you know, directing towards a particular website, or it could also mean that the link is, you know, broken. So users are not, you know, able to connect to the website. That way they are again and again clicking on that particular, you know, web page. And that way we can take an action as to, you know, to repair the, you know, that particular broken link. When we talk about data stream processing, so the next question is that how we are going to process this huge amount of data. So there are, you know, different types of algorithms for processing these streams, and the basic operation that needs to be, you know, used by these algorithms is the summarization of these streams in some way. So we can apply for different types of operations. Some of them could be like, for example, that we need to make a useful sample of the stream. For example, we need to filter a stream to eliminate the undesired elements from it. And sometimes we need to estimate the number of different elements in a stream, so that we are only, you know, storing the required information, and whatever redundant information we are having, we are going to not store it. So this is again is going to kind of saving, you know, storage for us. And one such approach for summarizing the stream is to look at only a fixed length, you know, window, which consists of the last or the most recent element. So majority of the algorithms that are there for data stream processing, they apply this approach because as we already have seen that stream is a never-ending concept. We are constantly getting data, and most of the time the application requirement is not to, you know, analyze the full data. Rather, the algorithm or the application wants that we need to be able to make the analysis based on the most recent data. So for example, if we need to find out some social media trend, we are not going to see, you know, all the 50 years data and all. We need to find out this kind of trending, you know, social media, you know, posts from the most recently posted, you know, elements. Next, once we know that how we are going to process the data, we need to pose the queries over this window, and we are posing the query much like we pose the query to a relational database. And another, you know, complexity aspect here is that if there are many streams and this window size n is very, very large, it may again pose some problem, and we will not be able to store even the entire window for every stream into the working memory to, you know, process it in real time. So we need to again summarize these, you know, windows. Now, we all have heard about the database management systems. So database management system is one software or tool that is being used to manage the data, and it provides organizing the data in a better way. And again, it provides tools and you know, the querying language associated with, so that posing different types of queries to find out insights from the data will be easier for the end user. In similar lines, the data stream management system is one such system that stores the streams data, and it is going to, you know, use this data, and some sort of mechanism will be there that through which we are going to, you know, pose different types of queries over the stream data. And each stream can provide elements at its own, you know, schedule, and any number of streams can enter the system. So a data stream management system can handle streams from multiple sources at, you know, simultaneously. Another important aspect of these data stream management systems is that the time between the element of one stream need not be, you know, uniform. So it is possible that we are having data at different, you know, rates arriving into the system. So maybe, for example, if one message has been received by the system right now, and after, you know, certain for example, 10 minutes, there would be, you know, 5 consecutive messages that the system is going to receive. So there is no predefined, you know, fixed rate at which, or fixed time interval at which these items are going to arrive into the system. So this diagram depicts the whole working of this data stream management system. So as we can see that there are certain components to it. We are having in the center the stream processor. So as the name suggests, the stream processor is the one responsible for processing the stream data, and two types of queries can be posed over the stream data. One are called as the standing queries, and the second one are called as the ad hoc queries. So the standing queries are the one which are fixed in nature. For example, if we know the type of stream data that we are recording here or getting here, then we can fix some sort of queries over that data. So those are called as the standing queries. Ad hoc queries are the ones which are more dynamic in nature. So we cannot predict what kind of query is going to be posed over this kind of stream. And mostly we can relate to these ad hoc queries with the user searches. So if you have used, for example, a web search engine, you know that we cannot predict that what kind of query a user is going to type into that search bar. So those type of queries or handling those type of queries is quite difficult task for us, and we need to know that how this stream data management system is going to to process these ad hoc queries apart from the standing queries. Standing queries are the continuous queries that are analyzing the data in as a continuous process, and they are generating the insights whenever the new data is going to be added to the stream. Now, as you all can see that there are different types of streams entering into the system simultaneously, and the system is going to store these streams into different types of storage media. So there could be one working storage that we can use here. So working storage, as the name suggests, is used for for processing the stream on the go. So all the real-time computations over the stream are going to be performed using this working memory, and archival storage is the one that is going to be used to store permanently some or part of the stream data or the full stream data as per the application demands. Now there are certain characteristics of the stream data. The rate of arrival of the stream element is not under the control of the system. When we compare this data stream management system to the database management system, we see that in DBMS, there is a fixed rate at which data is going to be read from the disk, and therefore we don't need to worry about that we are going to lose the data when we are executing the queries. But in case of stream data management systems, this kind of control is not there, because streams are never ending and we are getting data at a very high speed. So we need to keep track of all those data values so that our analysis and storage will be complete. Stream may be archived in a large archival store, but we assume that it is not possible to answer queries from the archival storage. And this property says that it is not possible to work over the whole stream data in real time, because that will be taking too long. And why? Why is that? Because the archival storage is going to store majority of the stream data, and as we say that whenever the data volume is going to be increased, the time to compute or analyze the data is going to be increased. So because of this relation, it is not possible to analyze the stream data while it is stored in the archival storage. Rather, we need to pick up some fragments of the data, and we are storing that into the working memory, and we are processing only that particular data from the data stream. It could be examined only under special circumstances. So there could be cases where we are referring to the archival storage, and we are making decisions based on processing of that particular data. And of course, it will be a time consuming retrieval and analysis process, because we need to analyze a lot of data. So maybe the system will be like, for example, that we are picking up chunks from this archival storage, shifting them into the working store, and then generating pieces of information or results from that, and then we are combining all that result to find out certain final results from this. Now, when we talk about the data stream storage model, the storage could be partitioned into three types. We can have a temporary working storage, we can have summary storage, and we can have a static storage for metadata. So temporary working storage is kind of a RAM that that is there into each and every computing system, and the RAM is limited in capacity, and that way it is providing faster computation and analysis time. And summary storage is mainly the archival, where we are going to store large amount of data which is already analyzed. And static storage is for storing the metadata or meta information. So this one diagram shows you how the whole system is going to be work, and there are different types of data sources. There are streaming message services, ingestion services, and this data is going to be stored for archival. And again, the data is going to pass to the stream processing engine, which is again processing the data, storing the results into the long-term data storage, and again generating different type of entities where this data is going to be used. So for example, the stream processing results may be utilized for generating the reports, for monitoring purpose, or for other workflows. So stream queries, there are two types of queries that we can pose over this: the ad hoc queries and the standing queries. And we already have discussed about the difference between the standing queries and the ad hoc queries. Now, there are certain applications of data streams: fraud detection, real-time good dealings. We can use the stream analysis into consumer enterprises, observing and describing on inside IT systems, sensor networks, network traffic analysis, financial applications, transaction log analysis, etc. Thank you very much for today.